Okay, we're going to look at another way of analyzing these circuits, and in this case we can actually solve for the voltages without the current. And remember that I just mentioned in the previous video that the larger resistor is going to capture more of the voltage. It's called the voltage drop. And the smaller resistor drops less voltage, but it always adds up to this source voltage, the 10 volts in this case, in this example. So what it ends up being is actually a ratio of these two resistors. So if we write that as an equation, we can find out that we can actually calculate these voltages without measuring the current at all, or calculating the current. So let me give you an example here. Let's say, for example, we're trying to figure out what the voltage is across this resistor. We're calling it R2. What does that voltage equal? Well, if we look at it as a ratio of R2 divided by R1 plus R2, what we're looking at there is a fraction here of that small resistance compared to the total resistance. And that fraction is, because Ohm's law is a linear equation, it turns out that if we simply multiply our voltage, V, times that fractional amount, we end up getting the total voltage across that resistor. Now, the way we can write this equation in a way that makes it a little bit more generic is like this. We can say VRX, and the X simply means which resistor we're measuring. Is it R1 or is it R2? And we also use X because we might have more than two resistors. We might have 7 or 8. It works with any combination. We can say that's equal to V, the source voltage, which is V1, times, and in this case, I'm going to say Rx, whatever the resistor that we're wanting to measure, divided by RT, the sum of all of those resistances. This formula is super cool because we do not need to actually measure any currents to figure this out. So let's plug in some values here and see how this works out. Okay, so let's start with R2 here. We'll start with a lower value. And we're going to say the voltage on R2, in this case, by just substituting these values here, equals 10 volts times R2 over what? That's the sum of those two values. So in this case, it's 500 ohms. We have 400 plus 100 is 500 ohms. Okay? And we know that R2 in this case equals 100. Sorry, I should have written that in as a value there. I'm also not doing a good job of putting in the subscripts here in the units, so sorry about that. Because the units are the same, ohms, we can cancel those out. What this ends up being is basically 1 over 5, or 1/5, and that's 20%, if you know some of these fractional values, and that ends up equaling 2 volts, if we did the math on that. Okay? So we'd have 2 volts across R2. Again, those are just, that's not a voltage source, it's just dropping that voltage. Now let's substitute the other values. Okay, so let's calculate for VR1 now. It's again going to be our source voltage, which is 10 volts. 10 volts times, in this case, 400 ohms, because that's a resistance value of R1, divided by R sub t, which is 500. So if we multiply that through, that ends up being 8 volts. That is VR1. And just like we calculated before, those two voltages end up adding up to the same as the source voltage. So we have 8 volts across R1. So that's using what's called the voltage divider rule. That's kind of a quick way to calculate just the voltages without the current.